Alright, so this experiment is about conduction heat transfer. Here this is the computer interface. But first let us go to the hardware. Okay, and here you have the hardware for the linear conduction module. In here there are three sections. The left section, we have the right section, and the middle section, or we call it as the central section. The left section is called as the heating section because we make use of an electric resistive wire to heat up this end. And the right section is called cooling section because we make use of, let's say, water circulation system to keep this section cool. So hence the name cooling section. And in the middle section we are going to place the test specimen for which we want to check the conductivity. So what actually happens is the heat that is given on this end will travel all through this metal inside, and then it goes into the test specimen. Through the test specimen it goes to the other side, which is the cooling section. So the movement of heat is from left side to the right side. You have the source of heat here. Electrically you are heating that side. So for the heat to flow in any direction, there should be a temperature gradient, meaning one side you should have high temperature, other side you should have low temperature. Only then the movement of heat takes place from high temperature to low temperature. This is what we have seen in thermodynamics and fluid mechanics, that fluids move from high pressure region to low pressure region, or the movement of heat is from high temperature to low temperature zone. So this side is high temperature and we are keeping this side cool with the water circulation system so that the movement of heat can take place through the test specimen. And once that happens, we can know the thermal conductivity of that test specimen based on how quickly or how slowly it is able to transmit the heat through it. Now I will open this up so that we can actually see the materials here. Okay, right in the center we see the silver color specimen. That is the stainless steel specimen which we are going to test for this experiment. Now the surrounding is just a coating made of Teflon, so that when we are trying to take the measurements, we don't get in contact with the high temperature surface which is at the center, which is the test specimen. Okay, so the test specimen is only the inner piece, and the outer white color is just a coating, and we don't take this in our calculation, the size of this coating. The diameter here is measured with a vernier caliper, or you can use a ruler to measure this diameter, and it is there in the manual. We can collect the diameter from the manual. So we will know the cross-section area of this specimen, pi d squared by 4. With the diameter measured, you know the cross-section area, pi d squared by 4, and that area goes in our equation for the calculation. Now if you can see the cooling side, there is again insulation, white color, and inside the insulation you have the material, a long cylindrical material is there. Okay, it is a bronze color. And same thing on the left side where you have the heating section. There is insulation, white color, and inside you have the bronze material, which is the material through which the heat flow takes place. So the movement of heat is through the cylinder, bronze inside, and it goes into the stainless steel, comes out from the other end, goes into the bronze material, this end. Okay. Right then, the means of heat transfer, we are calling this conduction because it is from one solid to another solid, and from the second solid to the third solid. So whenever there is movement of heat between the solids by contact, or in one solid through the length of the solid, then such type of heat transfer we call it as conduction heat transfer. Okay, so I'm going to put this back in here again. Before that, we have thermocouple sensors 1, 2, 3, 4 with the numbers. This is T4, this is T2, and here this is T1, T3. So 1, 2, 3, 4 for the hot section, and for the cold section you have 8, 9, 10, 11, 4 sensors along the length. For the test specimen, we have the sensor number 6, 5, and 7. They are in order, 5, 6, and 7. So 5 will be on the left side and 7 will be on the right side. So all we need from the machine, if we are trying to find the thermal conductivity of this material, we need delta T between the two sides, or for the length of the specimen. So T5 and T7, if we can record from the system, then I think with that we can do the calculation to find K value. Now I'm going to put this back in here.